Okay, so in this problem, there are 5 boxes which are arranged from left to right, and you have a certain number of coins with you, and you keep adding these coins to the boxes sequentially. So you start from the leftmost box, you keep going right, one box at a time, and whatever coins you wish to add, you add them there. And then once you finish box 5, you cycle back again to box 1, and then you proceed, right? So it goes like 1 2 3 4 5, and then 1 2 3 4 5, and so on, right? So the number of coins that you add at each box when you are at a particular box is given as this long number, right, that you have. That tells you what is the number of coins that you add at a particular box. So for instance, so let me take this example. I'll go in, and so let's take this example. This is the input that you are given. There are 5 boxes, right? Boxes are numbered from 1 to 5. So we'll call these rounds, right? So in the first round, what do? You take up the coin 3. So you take up 3 coins, and you add them to box 1. Okay, so 3 here denotes the number of coins that you add to box 1. Next, you take up 9 coins, you add them to box 2. So 7 coins go into box 3. So 397 289, right? 28. So 397 28, they go into the first 5 boxes respectively. So once you are done with box 5, what is the next number of coins that you have to add? You have to add 9 coins. So for that, you cycle back to box 1. So 4 goes to box 2, and then 910, right? 910. So there are 2 rounds here because there are 10 sets of coins that you are adding. Okay, you are doing this operation of adding coins to boxes 10 times. Okay, so the length of this, we are going to treat this as a string, or rather, so if you don't treat it as a string, if you want to treat it as a number, then the length of this number of digits in this number will tell us the number of times you are going to add coins to boxes, and the value of each digit, right, that will tell you the number of coins you're adding to that particular box. Okay, but you will see that it's a good idea to retain this as a string and not treat it as a integer, right? So this is going to be a string for us. So now what you do, once you finish this operation of adding coins to boxes, you count the number of coins in each box. So in box 1 there are 12 coins, box 2 there are 13 coins, so on and so forth. And you have to find out which box has the maximum number of coins. So box 3 in this case has the maximum number of coins. So if 2 boxes have the same maximum number of coins, you have to return the leftmost box, okay, the smaller of the two. So that's the problem. I hope you have understood what we have to do. Now let's make some observations. See, notice that every round is made up of 5 operations, right? So each operation is what? Dropping a certain number of coins into a box. So each round comes in multiples of 5, right? So if the length of the string is 5, that means there is one full round has happened. If the length of the input string is 10, then 2 complete rounds have happened, so on and so forth, right? The length of the string is actually tied to the number of rounds. So if you have something which is not a multiple of 5, let's say if length of the string is 7, that means one full round is done, and then 2 more operations are done, which means the first 2 boxes in the second round would have been filled with some number of coins, right? So that is what numbers which are not multiples of 5 would indicate. So they are like 1.5 rounds or 1.25 rounds, right? Whatever. So I hope you get the idea. So all this points to the fact that 5 is a very important number, right? So how is it related to solving this problem? For that, let's look at the most important thing here. So you can, now you are going to maintain the coins in each box, okay, in a list. Okay, so you'll have a list of size 5. Okay, so I'm going to call it boxes. So boxes will be a list of size 5, and to begin with, it'll have zeros. So there are 0 coins in each of these 5 boxes. So 5 boxes is represented by, each box is represented by one entry in a list, and I call that boxes. Okay, so the box indices are going to be from 0 to 4, correct? So 5 boxes 5 elements in a list called boxes, and the box indices are going to be from 0 to 4. Now if you look at coins, I already mentioned that coins is going to be represented by a string. So naturally there will be indices for each character in this coin, right? So I'm going to call this coin indices. Okay, so what is the coin index 2? Coin index 2 is going to correspond to this value of 8 coins. And where will you drop these 8 coins? You will drop these 8 coins into the box with index 2. Okay, so let me repeat that. So the coin index 2 is going to correspond to 8 coins that you have with you, which you are going to drop into the box with index number 2. Okay, so now if we can find out a mapping or relationship between the box indices and the coin indices, then that will help us in a big way. Okay, so that's what we are going to do next. Find a relationship between the indices of the coins and the boxes. So once you know the coin index, you know which box to put it into. So how are they related? This is how they are related. So if you notice, the box indices are 0 to 4. Now each of these remaining rows corresponds to one round. Okay, so if the coin index is 0, that means I drop it into box index 0, right? If the coin index is 1, I drop it into box index 1. This is easy. So I just keep doing this and I keep going until I reach coin index 4. That means 5 coins so far. So I drop whatever number of coins I have at coin index 4, I drop it into box 4, box index 4. Now I cycle back to the first box. Now notice that my coin index is now 5, right? So I keep doing this 5, 6, 7, 8, 9, and I cycle back to 10, 11, 12, 13, 14. Okay, now pause the video and ask yourself this question. Given the coin index, how do I determine which box index I have to put the corresponding coins into? Given coin index, how can I find the box index? Okay, so I think you'll be able to see this. If you are given a coin index, let's say 34, okay, let's say 34 is the coin index, then into which box should it go? It should go into the box index given by 34 mod 5, or the remainder when 34 is divided by 5, which is what? So when you divide 34 by 5, so 5 6 are 30, remainder is 4. So it will go into box index 4, or the last box, right? So if you want to verify that, so you have to just look at this pattern here, right? So all multiples of 5 go into box 0, right? So if you have something like 10, so 10 percentage 5 0, I'm just giving you examples, but then you can also in, prove this or try to understand this more abstractly, but I am taking up concrete examples. So all multiples of 5 will go into box 0, right? So if you notice, this is 0, 5, 10, 15, so on, below box 0, box index 0. Below box index 1, what will you have? One more than a multiple of 5. So you'll have 5 plus 1, 10 plus, so 0 plus 1, 5 plus 1, 10 plus 1, all of them, right? So meaning the remainder is 1 when you divide these numbers by 5, right? Here the remainder is 2, here the remainder is 3, here the remainder is 4. So if you are given a coin index, all that you have to do is coin index percentage 5, find out what is the remainder when it is coin index is divided by 5. The box index corresponding to this coin index will be the remainder when coin index is divided by 5. So this is the box into which you have to put this coin. Okay, so I hope that idea is clear to you now. So let's go back and take this as, let this also be in the background when we write the solution. Okay, so what we have to do now is we have to accept the coins as input from the user. So this is input of, I'm going to retain this as a string, and now I'm going to iterate over the coins. Okay, so for I, so let me use, this is the number of operations, right? Total number of operations. So for I in range of n, I is the coin index here. Okay, I is the coin index. So Now the box index is going to be determined by I percentage phi, right? So instead of calling it I, maybe it's better to call it coin index. Okay, so let me call this coin index. So now the box into which it's going to go is determined by coin index percentage phi. Okay, so first of all I need to have boxes, right? So there are going to be 5 boxes, 0 0 0 0 0. You could either do it this way, or you could just say 0 multiplied by 5, the singleton list containing 0 multiplied by 5. Okay, so there are 5 boxes. Now you have found out for this particular coin index, the box index is this. So now index into the box. Okay, boxes of box index equal to coins of coin index. Is this correct, or have I made a mistake? Okay, actually this is wrong because this is not equal to. I begin with 0 coins, but then I keep adding, right? So this should be plus equal to or equal to boxes of box index, whatever is the current number of coins you have in this particular box, add these many coins to that box. That's what we are doing here. So once you exit this for loop, what will you have? You'll have all the coins placed into their respective boxes. Okay, so now boxes is there with you. You have to find out that box which has the maximum number of coins, right? This is our usual routine for finding the maximum. So let's call it max box, the index of the box with the maximum number of coins, and max coins. Okay, so a good guess is index number 0, right? Box 1 has index 0. To begin with, what I can do is I can assume, I can make a guess that the 0th box is going to have the maximum number of coins. How many coins does it have? Boxes of 0. Okay, so this is a good assumption. Now I iterate through for box index in range of 5. Okay, box, so 5 boxes, so range of 5, 0 1 2 3 4. Now what should we do? If the number of coins in this box, okay, boxes of box index will give us the number of coins in this box. If it is greater than the max coins that we have found so far, then update the max coins to boxes of box index. Is that enough? No, you should also update which box this corresponds to, right? Max box equal to this box index. Okay, so now you have, once you exit the for loop, you would have found out the box with the maximum number of coins in it. Now all that is remaining is you have to print the index of the, yeah, max box, right? No, not just that. So it's not enough if you print the index. Let's go back. You have to print the box number. Okay, so box 3 in this case has the maximum number of coins. So you have to print 3. You should not print the box index, right? So you should print the box number. So what is the box number? It is one more than the box index, right? So if you recall, these are box numbers, these are box indices. So if the correct box index is 3, you have to print 4, which is 3 plus 1. Okay, so you have to print max underscore box plus 1. Okay, let's see if this works. Okay, so there is some mistake. What is the mistake in the code? Int and string are unsupported operations. So somewhere I have tried to add an integer and a string. It's in line 79 according to the test case area. So line 79 is this. Good point, right? So that's a good error to have. So I'm sorry to have made this mistake, but I'll make use of this. I'll use this as an opportunity to, show how debugging has to be done. So I made a natural mistake, right? Organic. I didn't plan for this. So 0 out of 7 test cases have passed. Okay, so it means something is wrong. So in the exam, if this happens, what you have to do is you have to go to the actual output area, right? So you have to look at the actual output area and look at the nature of the error. In this case, it's a type error. Okay, so what does it mean? Type error, in this case, the error message is also very instructive. It says unsupported operand type for int and str. So there is this plus operator Okay, the plus operator can be used to add two objects of the same type, right? I can either add integer and integer or string and string. I can concatenate two strings with the plus operator, but I can't add an integer and a string. Okay, that's the error message. So somewhere in my code, I have tried to add an integer and a string, which is why the error is happening. So which line is it? It's in line 79 and it is occurring at this particular statement, right? Where I am trying to add these two entries. Okay, let's go back to line 79 in the code. Okay, notice this. This is where the plus operator is there and I'm trying to add two things. So which of these is going to be an integer? Let's look at it, right? So boxes to begin with has only integers, right? So boxes of box index is going to be an integer, no problem there. Coins of coin index, remember, is going to be a string. Okay, so this is going to be a string. Why is it a string? Because coins is itself a string, and at no point of time are we converting any of the characters of coins into an integer. Okay, so that's the reason this error has come up. So what should we do? Before we add them, we have to convert this to an integer. Okay, now we are adding an integer to an integer, and hopefully it should work. Okay, so let's try to run this. Okay, so 7 out of 7 private tests have passed. Okay, so since there was an error in the code, what I'll do is I'll quickly delete the whole thing and redo it. So what is the idea? This is the idea. So you accept coins as input, okay, and you initialize boxes to zeros, right? You have 5 boxes to begin with. All 5 boxes have 0 coins in them. Now you iterate through the coins, right? So there are these many operations. So for I is perhaps not the right variable. For coin index in range of n, okay, range of the number of length of coins, that's what this is. Now you have to find out the box index. So box index is what is just coin index mod 5. Okay, the remainder when coin index is divided by 5, that is box index. So boxes of box index, okay, plus equal to integer, convert the coins. So coins of coin index, this will give you the number of coins at index coin index. Convert this into an integer and add it to this particular box. So now you have added all the coins in this in input into the respective boxes. Now assume that the max box, the index of the max box is 0 and the maximum coins as a guess is boxes of max box, right? You could either do this or you could say boxes of 0, both are the same at this stage. Okay, this is a good guess to have for the maximum number of coins. Now for box index in range of 5, okay, you are iterating through the boxes, indices of the boxes. If boxes of box index is greater than the maximum number of coins you have so far, then update maximum number of coins to be boxes of box index, and the maximum box index, right? So index of the box having the maximum number of coins, update it to box index. Okay, now once you keep doing this, you will end up with the box index which has the box which has the maximum number of coins. The corresponding box index is this. If you want the box number, actual number, you have to add 1 to the box index, okay, and print it. So that's the solution. Let's see if this works. Oops, okay, now we have 1 out of 7 private tests passed. So what is the error now? Let me go back. What have I? Okay, sorry. So again, I made a mistake. Instead of having max box plus 1, okay, sorry, this should not be. What should I print here? I should not print box index plus 1. I should print max underscore box plus 1. Okay, so that is what it should be. Let me run this. Okay, so that is 7 out of 7 private tests passed. Okay, so that is one solution to this problem. We can now make some small changes. So one change is the following: instead of having this loop for finding the box with the maximum number of coins, what you could do is, instead you have boxes, right? Boxes has 5 elements. You want to find the max of boxes. That's what you really want to do, right? But then you don't want just max of boxes, you want to find the index where this particular maximum occurs. You already know a list method to do that. What is that? Boxes dot index. As simple as that. So this will return the leftmost occurrence of max of boxes. Okay, I don't know if the spelling of occurrence is correct, but please fix that later on. So max of boxes will give you the maximum number of the maximum value in this list. You are now finding the index of this element in the list boxes. Okay, and that happens to be the index. So if you try to find boxes dot index of something, now it will return the leftmost occurrence. So for example, let's say boxes equal to 0 1 5 3 1 5, right? So 5 occurs two times, right? Now if you try to do boxes dot index of 5, that will give you the leftmost occurrence of 5, index of the leftmost occurrence. In this case it is, what is it, 0 1 2, so it will return 2. Okay, now this is actually max box that you're looking for, right? You have replaced that big for loop with a simple one liner. Okay, so boxes dot index of max of boxes. Now you can just print max box plus 1. Okay, so let's see if this works. Okay, so that is also a correct way to solve that part of the problem. Okay, there is one more variation which you could do, where you iterate through the loop using this enumerate construct, but for now I am leaving this out. Maybe we can take that up later. Okay, so thanks for watching.